Hello and welcome. My name's Alistair Leith. I'm Director of the Online Astronomy Society, and we're just going to kick off with a quick talk on Titan. A talk I did several moons ago, pardon the pun, and but by popular request I've gone and re-recorded it as the other one didn't go quite according to plan. So here we are. This is a talk on behalf of the Online Astronomy Society, and you can find us at www.onlineastronomysociety.com, and we've got a forum there as well if you put a / forum after it. So here we are. We're going to be presenting Titan, the Organic Wonder. I don't know why I've called it that, but there you go. A few facts about Titan, I suppose, before we go running into looking at the moon more closely. Firstly, needless to say, it's a moon of Saturn. It is the largest moon in the solar system. Please pardon the capital M if it's not our moon. It is a moon. So I've just actually stopped after previous recording to go and correct some irritating spelling mistakes. So obviously clearly missed that one. Strangely enough as well, it's the only moon with an atmosphere in the solar system, but which is very interesting to see. There's a lot more interesting facts about this atmosphere we'll discover going forward into this presentation as well. It was discovered by Christian Huygens back in March 1665. Interesting that he was able to discover it. I suppose the rings can often get in the way of the moons, at least in my experience. But nevertheless it was discovered back then. It's got a diameter of over 5,000 kilometres, which, to give you an idea, that's a fair bit bigger than our own moon, but needless to say a lot smaller than we are, we being the planet Earth. Orbital period 15.9 days, it's 16 days. In other words, it takes 16 days to go around Saturn. So there's a few basic facts of Titan. Early evidence of an atmosphere on Titan. Okay. The Spanish astronomer Joseph Soler, please forgive me if I've not pronounced that correctly. This is information that's been pulled off of the Wikipedia, by the way, so please forgive any factual inaccuracies based on that. But anyway, according to that, it was discovered in 1903 by the Spanish astronomer Joseph Soler, who noticed there was a darkening at the limb. This is seen when the moon sort of goes past Saturn, so you can sort of see it coming through that way. The observation of this was confirmed in 1944, so a fair bit later on, by Gerard B. Kuiper, who used spectroscopic techniques to reveal the atmosphere had partial pressure of methane. Something which is of immense interest to me, by the way, is getting spectroscopic analysis like that of atmospheres, something which I'm hoping to do a bit of work on later in life, or when I'm able to afford the kit. But that's what he did. And to give you an idea for non-chemists, methane is a hydrocarbon. It is the simplest hydrocarbon. It is the chemical formula is CH4. So it is one carbon atom with 4 hydrogens around it, basically. And that is of great interest to us, especially as we've got a very biased interest in finding life in the solar system, or indeed the entire universe other than us. And that plot's going to thicken now as this presentation goes on, so please keep that in mind. General comparison, I thought I got rid of that bullet mark, but never mind. Anyhow, I'm sure these objects don't need any introduction to you. Clearly we've got the Earth on the left hand side there, our humble moon on the right hand side, and you can see that Titan is sort of a middle person there. It's got a beautiful atmosphere, and you can sort of see a nice little fuzzy edge around the side there as well, which is probably brought on by light passing through it, maybe. But again, we'll be discussing more about that colour scheme and so on. It's as thick as soup, that atmosphere, and the only other object that's kind of like that I can think of off the top of my head is Venus. Very, very thick atmosphere, and we can't see through that. It's just totally opaque. Please pardon the fact if I've already repeated myself during the presentation. I'm sure I've mentioned that somewhere further on, but I will mention things again if I see it's topical at the time. But there's your general comparison for you. So why is Titan so interesting? Well, there's a number of objects which have raised interest, and we'll be discussing the other ones at the end of the presentation. But Titan is of interest to us because it contains building blocks essential to life, which include methane, as already discussed, but we've also got ethane. Ethane down there is the next most basic hydrocarbon that contains 2 carbon atoms and 6 atoms of hydrogen are there. I've just gone back. There we are. So that's ethane for you, and nitrogen as well. So what you've got there are some of the components needed to build life. Methane, nitrogen in particular, because they contain carbon, they're the simplest building blocks of life. Out of that comes things like amino acids, which contain carbon, hydrogen, oxygen and nitrogen. The John, we'll see later that Titan does actually have water on there too, so it really is possibly a place where life could, or it may have, or could certainly harbour life, either have it now or in the future. So it's, as I said, it's possible that primitive life could be found there. Can you imagine a world with methane lakes and rivers? I certainly couldn't. Rains methane as well. As a chemist, I know that to get methane, liquid methane in itself, you're going to have phenomenally low temperatures, which Titan actually does have. It's only minus 170 degrees there for the majority of the time. As we will see, Titan has interesting aerial views, which were sort of snapped by Huygens as she sort of plummeted down to the surface. But like Venus, the cloud cover is so thick that we can't see through it or past it. I'm going to mention here, I'm very sorry, but it will be mentioned as well later in this presentation, that there is no radiation that penetrates that atmosphere that we can see, and we can't penetrate past it to see anything. So it is that thick, and if it wasn't for Huygens, we would have no knowledge at all of what was underneath the atmosphere. But we'll take this tour in a minute. Titan's interior, I've pitched this off the Wikipedia site. As you can see, I'm not going to go through the whole thing, but it's just got an atmosphere. Please pardon the background noise. I'm recording this from my bedroom, by the way, and the window is open. It would be baking hot if it wasn't. We've got a silicon core in there, liquid water layer, high pressure and ices. That's kind of the interior of Titan. Exactly how they arrived at that, I believe they used a probe to scan it and get a general idea of what it was made of. There could be more involved physics than that, that's told them, but that's a bit beyond the scope of this presentation. The bulk characteristics of Titan are as follows. It's likely made up of bulk rock, 3,400 kilometers thick, surrounded by ice crystals. The interior might be hot with liquid layer consisting of ammonia and water. This is our Chon coming through, that's our water that's on the moon as well. Ammonia allows the water to remain liquid at temperatures of as low as minus 19 degrees Celsius. In other words, get water, put ammonia in it, and water won't freeze until you get down to about minus 19. Rough guess as a chemist, I mean, I guess that's antifreeze, isn't it? Same kind of idea. Evidence of the ocean came from Cassini's probe ELF, the extremely low frequency gadget that it uses, which naturally radiates from the planet. The surface is a poor reflector of ELF waves, so that's kind of what gave us the idea that the oceans on the surface. Not entirely sure as to how that works, but I thought to put it in for information purposes. Atmosphere is now known to contain, please pardon my spelling. I went through it earlier on, I must have missed that part. 98.4% nitrogen. Does that composition sound familiar to you from anywhere else? Well, I've given it away there. Only one body in the solar system other than Earth like that. The only other body in the solar system other than Earth like that. There are only two, Titan and the Earth. I'm making it sound like there's three. There isn't. But 1.6% methane with traces of hydrocarbons, helium and argon. This is what's in the atmosphere. Not too much methane there, considering how much we reckon is actually on the planet. So that's interesting. The orange breakdown which we discovered that we saw earlier on is a result of methane breaking down in UV light. So that describes the colour. Excellent stuff. That's a proposed atmospheric structure for Titan, based upon measurements and what we've seen so far. We've got lakes down there, we've got organic sediments, we believe there could be volcanism down there as well, although not in a sense of volcanic activity you're thinking of. And obviously what happens is the methane will condense up, will evaporate up I should say, and then condense back down again, which probably explains why there's not too much of it in the atmosphere. But there's a general kind of overview of the atmosphere anyhow. Feel free to pause at this point if you wish to study it further, but that came off the Wikipedia site just for reference purposes. Surface detail. Not much was picked up by Cassini or Huygens on the mission. However, those within the imagination focus and can see the possibilities. As we said, the atmosphere is totally opaque, can't see past it. I think they're able to do a quick radar study of the surface of Titan, which also showed there was limited evidence of any meteor impact, hardly any surface craters at all there really. Surface was by and large very smooth, and apart from the possibility of lakes, maybe a few rivers on there, but that's pretty much what we're able to find out. This is kind of an overview schematic. The white areas are the areas where the probe couldn't get to, but you can see there's a clear divide. There's a clear sort of contrast between land and illicit water, liquid area, should I say, of lakes and rivers and so forth. So it seems to be more sort of lakes and what have you in one area of the moon than in others for some reason, but there we are. And this is some snapshots taken by Huygens as it went through the atmosphere. As you can see, we've started up with the higher area views where we've seen, I suppose, some cloud and obviously clearly some evidence of lakes or oceans. On the right hand side, it clearly looks like a coastline there. You've obviously got some form of liquid in that lake. As I'd imagine being methane, it's probably going to be a very thick brown substance in there. And over there to the bottom left again, that could pass as a harbour. But again, as you can see, there's definitely some evidence of rivers, maybe lakes, perhaps even some flowing activity down there. And finally, down there on the right, I mean, has that landed in the partial lake? Possibly. I would hazard a guess and say maybe. But again, the only time I've seen a view similar to that has been when I've seen pictures from Mars. So again, some similarities there. Probably quite similar. I think it was even similar to one of the few shots we got from Venus. So this is some of the tantalising shots we've had coming back from Titan. Certainly very interesting. We said lakes. Yes, there's not enough of these to account for all the methane in the atmosphere. So they believe that the methane got into the atmosphere through some form of volcanic activity. Which I've not mentioned there, but that's what I discovered. The volcanoes are believed to be powered by radioactive decay. Why is there not more methane in the atmosphere, however? It's because it's believed to condense before it gets that high up. The methane is believed, as I said, to come from volcanic eruptions. So that's the general story there. Why then has methane not decomposed? Well, it's only just warm enough for water to exist as a liquid. So when we're talking about volcanic activity, we're not talking about humongous chunks of lava coming out at 10,000 degrees Celsius here. We're talking about methane coming out at a significantly lower temperature. So that's the kind of volcanic eruption to consider. And that's what's throwing methane up into the atmosphere, which then condenses back down, we believe. But it's only just warm enough in some cases for water to exist as a liquid. So that's just above 0 degrees Celsius, which of course is the temperature at which water freezes. So still, it's not warm enough at all to decompose anything. But I'm going to say now, but looking at that chemistry, you can only hazard a guess as to if Titan was where we are in the solar system. I mean, that is almost certainly going to be a candidate for harbouring life, without a doubt. In conclusion, it's certainly plausible, as I've already said, that Titan could have harboured life. I've just jumped the gun and get that right. I'm terrible for that. However, the temperature never increased as it did on Earth for this to happen. As the sun begins to die and expand, however, this could change, but not for long, as the sun then passes away. So it's quite probable that, a few thousand million years down the line, that the temperature could rise high enough for the hydrocarbons to start breaking down, to see this chemistry to start taking place on Titan, and the early forms of life to start coming about. So Titan certainly has the possibility and the potential there. I think which is why it's of huge interest to us. It certainly is a body which has potential to harbour life. So hence the interest. The atmosphere is so dense, I thought I'd throw that in. If you did stick wings on your arms, then you would be able to fly. So if you flap very hard, off you go. Titan's atmosphere is opaque at all wavelengths from Earth, so anything we fire at the moon will not penetrate. You won't learn anything from it, but I think I said that earlier on in the presentation. Titan's atmosphere is 970 kilometres thick. That's quite thick. Considering it's not smaller than we are and it's got an atmosphere that thick, the Earth is only 480 kilometres by comparison. So that's interesting, isn't it? That's like the Martian volcano of Olympus Mons in comparison to being the highest, the tallest mountain or volcano in the solar system. Nothing like that height here on Earth. So the solar system doesn't have consistency of size to ratio there, does it? So what next? Well, as I said earlier on, Titan's not the only one of Saturn's moons which has raised interest. As far as I know, we're not planning to go back there anytime soon to check it out, but there is interest in another moon called Enceladus. And Enceladus is one of these moons where we believe under that big thick icy surface that we can see that there could be life underneath that, which is another potential for us to perhaps go and pay more attention to. And there we go. That's a talk for another time. And of course, we're still interested in finding life on Mars as well. So these are three potential bodies where we think we could find primitive life. And that's what we mean by finding life, not finding something like Q or I. We're looking for microorganisms now, things which could potentially survive there. That's what they're looking for. And that ends that. So I'd like to thank you for watching, and I hope this has been informative for you. Thank you very much.